In Lab 1.3, the purpose is to use algebra pieces as a visual aid for representing and solving algebra story problems. We'll use part of the base 10 pieces, be using the tens and the units to represent our variables. So we're going to let the tens represent x, and then we'll let the units represent ones or any addition to x. So our x, which is this strip, is our variable, and these will represent our constants. So if I let x represent this, and I have two of them, then I have 2x. And if I have a unit added on, then I have 2x plus 1. And I could represent those by putting them horizontally, if you like, or I could represent them like I had them in the beginning, where they are each under the other. So the way they're represented doesn't really matter. If you have a statement that says 3 more than a number, if I let this strip x be the number 3 more than x, would represent 3 units and the variable. So 3 more than x would look like this. So you do this with me. If you had 2 more than 3 times a number, so I have 3 times a number, so that would mean that I would need 3 variables. That would represent 3 times the number, and then 2 more than that would mean 2 units. And so if I write that as a math statement, I would have 3 x's and 2 units. And so it's like apples and oranges. You can add an x to a unit. Those are separate. You can add x's to x's and units to units, and that gives us our algebraic phrase. We also can represent consecutive numbers using our base 10 pieces. So if I let this represent a number, then one more than that number would be the number and 1 unit. So if I let this number be n, then the next consecutive number would be n plus 1. The next number after that would be n plus 2. And the next number after that would be n plus 3, and so on. These are consecutive numbers. They're numbers one right after the other without skipping any. So this would be the number plus 3. If I want to represent consecutive even numbers, then they're going to differ by 2. Because if you think of 2, 4, 6, 8 as being the set of even numbers, you know that they're going to differ by 2. So if I have n as the first of the even numbers, then the next even number would be 2 more than that, or n plus 2. And the next even number would be 2 more than that, or n plus 4. So we have n plus 2 and n plus 4. And then the next would be n plus 6. If you want to represent consecutive odd numbers, you know, 1, 3, 5, 7, 9, those differ by 2 as well. And so there would be no difference in how you represent those with the variables. So if I let this be the first of the consecutive odd numbers, n is the first odd, then the next odd number would be n plus 2, and the next odd number would be n plus 4. So there's really no difference in how consecutive odds and consecutive evens are represented. All right. Let's now represent the sides of a triangle. So I'm going to give you the clues, and then I'm going to give you a minute to see if you can use your manipulatives to set up the situation. It says that the second side of the triangle is twice the length of the first. The third side of the triangle is 6 units longer than the second side. So either use the manipulatives or draw it out so that you have created a triangle. So if we say the second side of the triangle is twice the length of the first, if I let this be the length of the first, then the second side would be twice that. Then the third side of the triangle is 6 units longer than the second. So I would take these two lengths, I should be putting them side by side, these two lengths, and then I would have 6 units more. So maybe if I turn them this way, you would be able to see all of the lengths. So this is the first side, this is the second side, and then here is the third side with these 6 units, and they don't all have to be on the end, they have to be somewhere, but you're not going to be able to see them all, I don't think. So I have one long strip, two long strips, two long strips, and 6 units. And I want to make these fit into a triangle, so I'm going to have to maybe make the triangle look something like this. So it's going to be an obtuse triangle because I have one obtuse angle here. Can't hardly see all of it. If you sketched it out, you would want to sketch side 2, then you could sketch side 3, and then side 1. Now we're going to take this information and add some more to it, and we're going to say that the distance around this, which is the perimeter, is 66 units. So if I let n represent the first side, 2n would represent the second side, and 2n plus 6 would represent the third side. These three sides would have to add up to be 66. So we could set up an equation that 66 is equal to n plus 2n plus 2n plus 6. Remember, this is 1, so that makes 5n plus 6 is 66. And we'll subtract 6 on both sides. Divide by 5. and N would be 12 units. So that would be the length of side 1. Then 2N, which is 24, would be the length of side 2. And then 2N plus 6, which would be 30 units, would be side 3. Now we always want to check to make sure that those numbers add to be 66. So we'll take 12 and 24 and 30 and add those together, and we do get 66 units. So we found the correct dimensions for that triangle. When we deal with money, we take the value and we multiply it by the number of coins or bills that you have. So if I have 10 quarters, the value of that quarter is 25 cents, and I'm going to multiply it by the number I have, and that gives me how much money that I have. Let me caution you when you write money. You can write 25 cents like this with a decimal and a dollar sign, but you cannot write the decimal and the cent sign. This means you have 25 hundredths of a penny, and that's incorrect. And so you could write it like this with the cent sign. So if I have a box that contains $2.25, and in that box there are nickels and there are dimes, I know that there are 3 times as many nickels as dimes. So what you have to think about right here is which one do you have more of, nickels or dimes? If you have 3 times as many nickels as dimes, you have fewer dimes. So if I let this represent the number of dimes, then I have to have 3 of these to represent the number of nickels. And so now back to our rule, we have to take the value of the coin times the number of coins that we have. So the value of the dime is 10 cents, and I have 1. And the value of the nickel is 5 cents, and I have 3 times more. And altogether I have $2.25. So that creates our equation. Now we have a rule. If we have decimals, we can multiply by 100, and that moves the decimal right 2 places, and we now have an equation with no decimals, and it looks much more friendly. First, I will multiply, combine like terms, and divide by 25. And that goes 9 times. So I would have 9 dimes, and I would have 3 times that in nickels. Okay, I will have a problem for you to do on Blackboard that will sum up um, this lab.